I'm Anil Kumar, and here is another interesting video on reflections of functions. The question is, if f of x equals to square root of x plus 3, write an equation to represent y equals to f of minus x and describe the relationship between the two functions. So what we are given here is f of x equals to square root of x plus 3. Let us first write y equals to f of minus x. So y equals to f of minus x really means that we have to change the x to minus x and rewrite our equation. So this is what we get. Now this equation you can also write as taking minus common, we get x minus 3. Do you see that? So that is what we get. Now here, if I have to sketch this particular function, what really happens? Let me describe this transformation. This transformation is, if we have square root x, then minus means it is reflected. So instead of going towards the quadrant 1, it will actually go from here to that side, and then minus 3 means moving it 3 units to the right. So basically what really happens is that the whole curve here for the given function f of x actually gets reflected, right? So basically what really happens is that we get a square root function which is kind of reflected on y-axis. So what we observe is that each point on the given function is reflected on the y-axis. Correct? That is what we observe. You can very clearly see. So the characteristics which we observe here are a couple of them. One, that the two graphs are congruent, so we get congruent graphs. As there is no stretch or compression involved, only reflection, right? So it is reflection only, right? And they are congruent and they are symmetric about y-axis. Do you see? So it is reflection on y-axis. They have a common point when x is equals to 0. So when x is 0, they have a common point, right? So which is square root of 3. So that is 0 square root of 3 is invariant. And you also see that in these two graphs, range remains same. That is, you can write range as, better to write in curly brackets, y belongs to real numbers where y is greater than or equal to 0. But the domain changes. Do you see that? Domain changes. So in f of x, the domain is x is greater than or equal to minus 3. For f of x, the domain is this. For f of minus x, the domain is x is less than or equal to 3. You see? So that is a major change which you observe in this particular graph. You would also write that x-intercepts are mirror image. Correct? And what you also observe is that the first graph, which is f of x, is always increasing. However, f of minus x is always decreasing, is always in its domain, of course, correct? So that is what you observe, and that really indicates that when x is approaching positive infinity, the first graph is approaching positive infinity, the second one is approaching positive infinity when x is approaching negative infinity, right? So this I could say as when x approaches negative infinity, y approaches positive infinity. This is for the reflected graph, and for the original one, when x approaches positive infinity, y approaches positive infinity, right? So these are some ways in which you can describe the two graphs and show them on a particular graph. I hope that helps. Thank you and all the best.